All right, we didn't really get an opportunity to go through this very carefully, so I'm going to let you guys peruse this now at your own speed. And so now Gonstead, I went through this stuff fairly quickly, but you notice that the leg changed after adjustment. That's nothing new. We've seen that in chiropractic for a long time. He wondered if it was consistent. So it actually was consistent. And you can imagine him doing x-rays to do comparisons before and after adjustments. And what he found was there's a 5-to-2 relationship. That means for every 5 millimeters of ilium shift, there was a 2 millimeter femur shift. And that's going to vary from person to person, but this 5-to-2 relationship is pretty consistent, okay? So we're going to call it a 2-to-5 ratio. A little bit cumbersome to work with. So what we're going to say is that the femur is going to shift a total of 40% of whatever distance the pelvis does. So if it moves 10 millimeters, if you see the combined pelvic numbers at 10, you're going to see 4 millimeters of shift in the height of the femurs. So the 0.4 is what we're going to work with rather than 40%. That is a constant. That 0.4 is a constant. Every time, students always say, well, where's the 0.4 come from? That's the 2-to-5 ratio, 0.4. Just going to use it every time. So we're going to look at this first, what I call the logical way. And this is if you're not really particularly math-minded, if you don't like plus and minus signs and stuff, just use this way now. I'll demonstrate what I call the mathematical method. It's fairly simple, but if you don't like math and plus and minus signs, it'll drive you bats. So first thing we're going to do, just for simplicity's sake, no matter what the actual listing is, for this calculation, use the listing on the short leg side, on the side where you actually do the measurement for the MD, right? So the first example we have here is a PI4 EX3 on the right, and then a right MD of 6 millimeters. Okay, the PI, the listing itself, is on the same side as the short leg. So we just go ahead, and again, this is just to keep your world simple. You can do it any way you want, but this keeps your world simple, all right? It's a good way to learn. So in that case, the short leg and the listing are on the same side, so we don't do a change. In the second one, our patient has a PI4 EX3. This is on the left. The short leg, the MD, measured deficiency, is on the right. So that means that at some point we're going to have to make a transition. We're going to say, okay, this PI, this EX are affecting the left side a certain way, but then we got to switch it over to the right. So why not go ahead and do it up front? So we'll just use the listing that's on that short leg side. So if I got a PI on the left, it means I've got a compensating AS on the right. You've got an EX on the left, you're going to have a compensating IN. So the listing on the opposite side of the actual listing we're going to use is the one we'll use for the calculations of the AD. All right, so the listing is opposite the short leg. So use the listing on short leg side, AS4, IN3. Notice the subscripts don't change, right? So it's going to sort out the movements. Whatever the listing is on that side, we've got to combine the two numbers either by adding or subtracting. So we said PIs and EXs will bring the femur heads up when we correct, and ASs and INs will drop the femur head when you correct. So if you've got that combination or this combination, they're both working the same direction. You combine the power and you add the two numbers together. On the other hand, if I've got the PI is going to bring the femur head up, but the IN is going to make the femur head go down, one part of the listing is going to wash out the other part of the listing. Same thing if you have an AS-EX. The AS will make the femur head drop, the EX will make the femur head rise. So in that case, since they're not working together, they're not combining the power, you get to subtract each of the subscripts. And I usually just take the biggest one minus the smallest one. Okay? So here's some examples. Well, when we get to some examples. PIs and EX bring the femur head up after the adjustment. ASs and INs will drop the femur head after the adjustment. So if both half of the listings are on the same side of this center line right here, add them. They'll work together. If you got one listing on one side of the line and the other listing on the other, like a PIIN or an ASEX. They're working against each other. They're going to wash part of one is going to wash part of the other one out. So you subtract them. If one's above, one below, subtract. That's what you do with the subscripts on the original listing. That's our first step. And then we'll hit that number, whatever's left over, with our constant. There's our 0.4. That's the amount of femur correction that's going to occur. So you get a net movement in the pelvis first, then you hit it with the constant. So the femur will shift that distance as a result of what we do when we adjust the pelvis. So which way did they go, George? The listing is an AS or IN, or if the bigger subscript is AS or IN, your movement of the femur will be down, and so the measurement, the distance between the two femurs, will grow larger. Okay? Femur head on the short side is going to be going in an inferiorward direction when you correct the pelvis. And yeah, some people really don't like it because it makes the leg appear shorter. It makes the leg worse. Well, you know, we don't live in a perfect world. I'm one of those examples of a situation where after an adjustment, when my pelvis is adjusted, my leg length actually gets a little bit worse. That's okay if there's a certain cutoff point where we don't have to worry too much about it. So, on the other hand, if your listing was a PIEX, or if the larger subscript is PI or EX, then your correction is going to bring the femur head up. That's what everybody loves to have happen because the legs get closer to level and life is peachy, right? So we're going to add or subtract. Now, if the direction of the correction raises the short femur head, that means the legs are going to get closer to balance. Then you're going to subtract the shift from the original measured deficiency. Subtract the femur correction from the measured difference. On the other hand, if the correction lowers the femur head, if the femur head's going to drop as a net movement, then you're going to increase the distance and you'll add the two numbers. I always say if the numbers are going to get smaller, in other words, if the femur head distances are going to get closer, you get smaller numbers by subtracting. If you're going to wind up increasing the size of the femur head, or the distance between the femur heads, then you get bigger numbers by adding. So that's one way to remember that. Once in a while, you'll get something weird. You say you subtract. The femur head's coming up, and it moves so far that you actually get a negative number. In other words, I had 3 millimeters of measured deficiency to begin with, but the femur shifted 4. So that means when the 3 millimeters were gone, it was level, and it kept going. So now, if you get a negative number on the other side, all that means is the heads have crossed over, and now your short leg is on the other side. Forget the minus sign. It's going to be 2 millimeters on whatever the other side is. Okay, so say the absolute value of the answer. That means take the minus sign off. Okay. All right. That answer that you get after this whole rigmarole, I can't say the word, rigmarole, is your AD, your actual deficiency. Actual difference, actual deficiency. Some people say anatomical, but you can't really tell that with the x-rays that we have. There could be other stuff going on, so we're going to say actual. It's the deficiency that's left over when you're done adjusting it. AD after you're done. So that's another way to think about it. So here's some examples. Let's see if I can get my marker to work right here. All right, so now we've got an example here. I've got an individual who's got an AS of 6 and an IN of 4 on the left with a measured deficiency of 3 on the left. You can see how this femur head here, this femur head has dropped down, right? So relative to this other side here. So what we have here, the AS, remember we have PI and EX. When you correct the pelvis, will bring the femur head up. AS and IN on correction will bring the femur head down. So this guy's got an AS, which is going to draw the femur head down. And he's got an IN, which is also going to draw the femur head down. And so that means this guy's net movement is going to be down. I'm going to change my color and make it a little bit easier to see. So we got the femur heads both coming down. Both of those guys bringing the femur head down. So our net movement is going to be this femur head's going to wind up lower when we're done. All right, so we take our numbers. So 6 millimeters and 4 millimeters, since they're both going the same direction, we get to combine the power. So that's going to give us 10 millimeters of net ilium movement. Okay. Hit it with the constant times 0.4. That's going to give us 4 millimeters of shift. That's how much this femur head right here is going to shift. Okay, whichever direction it's going to go, right? So let's clean that up a little bit. So that's how much shift is going to occur right here. So let's take the original measured deficiency of 3 and just stick it down here, 3. Now let's decide, is it going to be a minus or a plus? Well, the femur head's going down in the long run. So if we were to remeasure it later down here, we would expect a bigger number, wouldn't we? So you get bigger numbers by adding. So that means this is going to be 7 millimeters of AD. And by golly, look at that. I got the number right yet again. That's exciting. All right. So let's move on to our next one. And so now I'm going to have to... So how about this? Over on the right, we've got a PI3 and an EX2 and an MD of 6 millimeters. So far we've had the listing on the same side as the short leg every time. So life is, it's kind of easy. So we know PIs and EXs on correction are going to bring the femur head up. ASs and INs are going to bring the femur head down, right? So this guy, the PI is bringing the femur head up. The EX is bringing the femur head up. The two are working together, so we combine the power. 3 plus 2 is going to give us a total 5 net millimeters of movement at the ilium. Times 0.4, we're going to get 0.4, 40% of this number here happening at the femur head. So 0.4 times 5 is going to give us a 2.0, right? Take the original 6 and put it here. Now you'll notice I'm getting a pattern here, right? I'll point the pattern out in a second. So then since these femur heads are coming up, this is coming up, this is coming up, we would expect when we're done to have a smaller distance between the femur heads. We would see the femur head position up here somewhere, right? So you get smaller numbers. That distance would be smaller there, right? So you get smaller numbers by subtracting. And so we'll wind up 6 minus 2 is going to give us a 4 millimeter AD on the right side of the pelvis. And ooh, look, yet again I got it right. And so hopefully you're getting an idea how this whole thing is going to work now, right? So now we've got a PI2 IN14. Okay, so this is the first time now that we've got things that are working against each other a little bit. So the PI will bring the femur head up. See, here's one femur head here, and here's the other femur head over here. Right? PI brings it up. The IN is going to bring it down because PIs and EXs bring the femur head up. ASs and INs take the femur head down. So they're working against each other. So if you'll take the 14 minus the 2 is going to give you 12 millimeters of net movement in the ilium. Okay, 12 millimeters of net movement in the ilium times our factor, 0.4. Okay, 12 times 0.4 is 4.8 millimeters of shift. That's how much movement's going to occur in the femur head. We're starting out, take our original 2 up here and put it back down here. Now do I add or subtract? Well, if I have more up with the femur head, we would subtract it because we'd get a smaller number. In this case, I don't have that going on. I got more down. So we would expect the new femur head position to be here somewhere, for a bigger measurement, right? So that means to get bigger numbers, you got to add. So this guy's going to wind up with a larger distance when we're done, is the point. So 2 plus 4.8 is going to be 6.8 millimeters AD, and this is on this patient's left side. 6.8 millimeters AD left. So here we got a situation where the listing is on the left side. Remember, whenever we're looking at these things, left is left, right is right. There's one femur head, and that line right on top there is just the continuation of this line over here, right? And over here is our actual short leg. That's this femur head over here. So you could pay attention to what's happening here and say, well, this femur head's going to go down here, and so then you have to translate it to what this line is doing, and you could do that, and that'd be fine. It's easier if just for the purposes of the calculation. This guy, this is the listing that my patient has. It's based on the lumbar spine being a body left, and that's why we picked the left side, and that's the most likely subluxation. That's why that's like that. We're going to use, though, the compensating listing, because when you correct this thing over here, the compensation is going to correct as well, and it's going to affect this head directly. So it'll work either way. It's up to you how you want to do it. But this is the PI 14, and this is the EX 4. And the only reason I recommend using this listing right here, it just makes your life a little bit easier. So we know PIs and EXs. Bring the femur head up. Are you getting tired of this yet? ASs and INs make the femur head go down, right? So this guy's got a PI, which is going to bring the femur head up over on this side. It's got an EX there. They're bringing the femur head up. Oh, they're working together. They combine their power. Oops, you know what? I made a boo-boo. The guy's got an EX over here on the left. That means over here he doesn't have an EX. He's got an IN. So they're not working together. That's not happening. The PI is going to bring the femur head up, but that IN is going to take it down. Now pay attention. We've got more PI than we do IN, so that's going to make a difference in a minute. So we've got the 14, and since they're not working together, you subtract the 4. And that gives you a net movement of 10 millimeters up here in the pelvis. Okay, up here in the ilium, right? 10 millimeters. And we got to multiply it times 0.4. That's our constant. So that's going to give us 4 millimeters of shift in the femur head. Take your original MD of 6, put it into the listing, 6. Do we add or subtract? Well, I had more PI than I did IN. So PIs bring the femur head up when you correct them. So that's this guy's net final movement. So it's going to be a smaller measurement when we're done. 6 minus 4 is 2 millimeters AD, and it's on the right. All right? That's how this whole thing works. Pretty simple, right? Hardest part's sorting out the which way the, how much of each thing we have. In this case, we had PI on one side and IN on the other, so they weren't working together. So that's the hardest part, and a lot of people get stuck with what to do here. So we could do this. I'm going to take a little side trip, a little rabbit trail here. We could do this mathematically. Now, in a mathematical method, you got to give things plus and minus signs. So any PI or EX is going to get a plus sign for the subscript, and any AS or IN is going to get a minus sign for the subscript. And then you, at the first part, now here's my pattern I was talking about. I go across this way and down, and then back over like that. And that's a systematic way to do it. I'm probably most of the time I do this in my head, but if you're thinking about doing this, in a systematic fashion, I go across and down, and then straight across like this. So if we can do this using these pluses and minuses, then I can say, okay, the 14, that's a plus 14. And we're just going to add every time. We don't have to worry about anything else because the signs will take care of it. Minus 4 will give me a plus 10 times 0.4. And that gives us that's a plus 10, so we're going to have a plus 4 here. Okay. And we'll take our original 6. And if you're working on the short leg side, just always subtract, and it'll work out. So that's going to give me the 2 millimeters. So it'll work either way. And I'll show you another example in a minute where you can do it mathematically. This is a logical style. It works beautifully where I'm just thinking about which way they went, right? Okay, that's really messy. Let's clean that up. PI4, EX8, PIEX, ASIN. PI's and EX's go up, AS's and IN's go down. So I've got a PI4, EX8. PI brings up, EX brings up. The two of them are working together. I get 4 plus 8 is 12 times 0.4, 4.8. Shift. This is the net movement. I've got 2. Remember my original 2. We're always going to bring it down here. 2 millimeters. Now, do I add or subtract? Well, this femur head on this side, because it's PIEX, the femur head on that side right here, this femur head, is going to wind up going up. Generally, we're thinking smaller numbers, so we're going to subtract. So 2 minus 4.8 is going to, oops, we get a negative number, negative 2.8. Now, the way I think about this, I just say, oh yeah, minus sign. That means this thing moved, this femur head here moved to it moved a total of 4.8 millimeters. The first 2 millimeters got it level. The next 2 millimeters made it so that this is now the high femur head and this is now the low femur head. So this one's going to be, this is where the other 2.8 millimeters went. So whenever you see that minus sign right there, just switch sides. This was a left MD of 12, so now it's a right AD of 2.8. So if you'll start with the measured deficiency there and then do the math function in that direction afterwards, if you wind up with a negative sign here, just switch sides, switch it from left to right, right to left, and that'll take care of that. Okay. PI12, IN2, that's the femur head on this side. This is the femur head over here. We've only got 2 millimeters of measured deficiency. So the PI brings the femur head up. The IN takes the femur head down. They aren't working together, so 12 minus 2, since they're not working together, is 10 times 0.4. Gives me a net movement of 4. Take the original 2. What do I have the most of? I have mostly PI. So that means you're going to subtract. Negative 2. What did I say when you see a negative number here? It means switch sides. So he was on the right. Now he's going to be a left AD of 2. Pretty straightforward. So let's see. Yeah, see if I got another example that'll work a little differently for the math. All right, so here we are on the opposite side. Not a big deal. AS2, IN3 are listing over here. PI2, EX3. So what do we got? PI brings it up, EX is bring it up, right? PI, EX, over AS, IN. That guy brings it up, that guy brings it down. Keep writing it so you guys will remember that. So we're going to have a net upward movement. So we'll take the 2, plus the 3, since they're both working together. It's going to give us 5 times 0.4. 2 millimeter shift. We start out with the 2 millimeters here. Since it's a bigger numbers of PI or in EX, we'll wind up subtracting. And that gives me a 0. That's what everybody has been wanting the whole time, right? You want to have perfect legs afterwards. So, no leg length inequality. Guy's got 0. Now, one thing about leg length inequalities. The body can tolerate, and this will sound a bit familiar, up to about 6 millimeters. And give or take, maybe a little bit more, maybe a little bit less. But if we're talking about, is this a significant amount of leg length inequality? Could it be affecting their pelvis adjustment or something else in the spine? Generally under 6 millimeters, not so much. So we said on the sacrum that if we had 6 millimeters or more of difference between the left and the right side of the sacrum, then it would be a significant sacrum. Same thing on the short legs, on the AD. If the AD is greater than or equal to 6 millimeters, okay, then it's significant. Right? I love my handwriting. So just a note, 6 millimeters or better on either the sacrum or the AD is going to be considered significant. Okay, under 6, not so much. All right. I think we got one more here. Oh, well. This one again, you know, got this little ball of wax here. Whoops. Down. PIEX, ASIN. So this guy has an AS of 5 and an EX of 5. So the AS is going to make the femur head drop. The EX is going to make the femur head climb. They're working against each other. So guess what? 5 minus 5. 0 net movement in the ilium. So times 0.4. 0. Start it with the 4. Add or subtract, it doesn't matter. It's 0. 4 plus 0. You still have 4 millimeters of actual deficiency, and it's still over there on the left side. All right. So now here's a couple. This is the mathematical style that I was talking about. Again, we're going to go on the short leg side. We add the short leg listing, assign the subscripts. AS and IN subscripts get a negative sign, and the PIs and AX are given a positive sign. Then you get to do your little bit of math, add the subscripts for the listing. Okay? So PI 8, IN 6, that's a plus 8 plus a minus 6. Okay? So that's a plus a minus 6. You see that? That's the same as subtracting, as saying minus 6. Plus 8 plus minus 6. That's going to give you 2. All right. AS8, EX6, same type of deal. We're starting with the negative 6 here, plus the positive 6 here, and that's going to wind up giving you a negative 2. Now, this doesn't mean we've switched sides yet. All this is going to do is it's going to play into the rest of the equation, sort of make it work automatically. So PI8, EX6. Now these guys are both positives, right? So that's a positive 8 plus a positive 6, going to give a positive 14. It's important that you hang on to your subscripts over here on the answer, because those are going to come in handy in a minute. And AS8, IN6, these are both negatives, so you got a negative 8 plus, that's really what we're doing, plus a negative 6 equals a negative 14. And on each of those, you'd hit them times the 0.4, right? That's where that's going to go ultimately. So negative answer indicates femur heads on the short sides are going to be going down after correction. Okay, if you wind up with that net answer here, this means right here, because it's a negative answer, you're going to have the femur heads are going to be dropping. If it's a positive answer, the femurs are going to be going up. But that doesn't really matter. Again, this is going to be kind of an automatic thing. Okay. We apply the constant, just simply multiply times 0.4, just like we've been doing. What you wind up with is the femur correction. Hang on to the sign. And then apply the shift. Subtract. In this case, as long as you start on the short leg side, just subtract every time. Just subtract. And that's the nice part about this. You don't really have to think about it. Okay? Remember, you got to hang on to those signs, though. As if you got to hang on to the signs. Subtracting a negative minus a minus, that turns into that's the same as adding, right? So that's going to be important in a minute. So sometimes you get that weird answer. If you subtract and get a negative number, it just means the femur heads have crossed over. If you started out with a right short leg, what you'll wind up with a negative number just means it becomes a left. That's all that happens. So now the opposite side short by the absolute value of that answer. Okay? Answer is your AD, the anatomical or actual difference. I think actual is probably the most accurate way to say it. That's what's left over after the adjustment. Okay? Now, with the mathematical style, if you chose the long leg side to do the calculations, in other words, you didn't use the short leg, then you get to just switch the actual function at the very end. Instead of subtracting, you add the very last equation. Okay? At the very last step, you add rather than subtracting. If you're always using the short leg, you always subtract. You don't have to think about it. Answer should be the same. So here's the same thing again. We looked at these already. That's in this case, minus 6, minus 4. So a minus 6 plus a minus 4 gives you a minus 10 times 0.4, right? So you have a minus 4. And we take the original 3 and you subtract the minus 4, which is the same as adding, and you wind up with 7 as your final answer. See? So it works out. Minus 4, right? Yay! Here, same side, so we can go ahead and use that listing. That's a plus 3. Plus, then that's an EX. That's also a positive. Okay, remember, PIs and EXs get plus signs. ASs and INs get minus signs. So a plus 3 plus a plus 2 gives you a plus 5 times 0.4. That gives you a plus 2. Take your 6, and since we're doing it on the short leg side here, everything's on the short leg, you just subtract. 6 minus a positive 2 is 6 minus 2, and that's 4. Yay, we got it right again. Hey, wake up. I'm pretty sure I put you to sleep by now, right? Okay, so stay with me. Here we got, same side. So we don't have to worry about the listing on the other side. That's a plus 2 plus a negative 14 is going to give you a negative 12 times 0.4 is a negative 4.8, right? And you take your original 2 and you subtract that negative 4.8, okay? Yeah, so everything's good. So you have actually 6.8 is your AD. That's 6.8. All right, and that's going to still be over there on the left-hand side. So that's the AD on the left. Right? AS14EX4. Easier if you just go PI14 IN4. That's a plus 14 plus a negative 4 equals plus 10 times 0.4 gives you 4 millimeter shift. That's a plus 0.4. Take the original 6 right there, 6 millimeters. That's a 6. And we just always subtract. And that's going to give you your 2 millimeter AD on the right. Remember we said that the AS over here, that PI will bring the femur head up and that IN will take it down. We got a lot more up than down, so we're expecting a smaller number when we're done. Right? So it still works out. This is just automatic. They're already on the same side, so that's a plus 4 plus a plus 8 is plus 12 times 0.4 plus 4.8 started out with a 2 minus the plus 4.8, that's going to give us a negative 2.8. Remember we said that's the crossover. That right there tells you it crossed over. So now instead of being on the left side, it's going to be over here on the right. So it's a right AD of 2.8. Okay. So I see the math. If you can handle doing this, it's pretty quick. Plus 12 plus negative 2 plus 10 times 0.4. Wake up. Plus 4. Taking the 2 from right there. Minus the plus 4 is going to give us 2. Right? So remember we said the PI is going to bring it up. The IN is going to take it down. Negative 2. So that means that this one crossed over. Now this is, instead of being on the right, it's a left AD of 2 millimeters. That's one of your crossovers. And then this one you can look at. You can say the AS is 2, the IN's 3. The two of them are going to add up to be 5. And that times 0.4 is going to be 2. And since over on this side it would be a PI EX, that means it's going to come up, so you'd subtract it. Mathematically, you got the PI2, EX2. So that's plus, sorry, EX3 plus 2 plus 3 plus 5 times 0.4 plus 2, and if you take the 2 and you subtract the plus 2, that gives you 0. Okay. So it works out either way, logically or mathematically. We already said this one. You can look at that one, AS5, EX5. That's going to totally cancel it out, so your MD and your AD are equal. Mathematically, minus 5 plus a plus 5, sorry, 5 not 15, is 0 times 0.4, 0. 4 minus 0 is 4. See, works out mathematically either way. Hell yeah, hope you're not too bored. So, now do you need a heel lift? We'll probably touch on this again in class, but if you've seen it, it'll be a little bit easier for you. So first off, answer to the following question. You have to have yes to these questions in order to use a heel lift. If you don't have yes to both questions, don't use a heel lift. So number 1, is the AD equal to or greater than 6? Okay, we already said 6 millimeters. Or greater is what we're going to consider significant for most folks. That's our starting point. So that's number 1. If that's true, keep going. Okay. Convexity of the spine to the side of the short leg. In other words, if I've got a short leg, over here, longer leg here, I'm going to have a convexity of the spine to that side. So the concavity is toward the long leg. But that's what the spine's going to look like. It doesn't have to be that bent, but that's what the spine's going to look like on the short leg side. Right? And is the body rotation of the lumbar spine toward the short leg? Do I have normal biomechanics? When I've got a curve like this, the spinuses usually go to the inside of the curve in the lumbar spine, don't they? So the body side of this vertebra needs to be on the short leg side. All right, and I'll show you an example in just a minute. So those are your questions. Is it greater than 6 millimeters of deficiency? Is the convexity on the side of the short leg? And is the body side of the lumbar on the short leg side as well? And that's because when we try to straighten this spine out, we want this spinous to come more to neutral as we correct. So if I've got a situation where spinous is over here and my short leg is here, as we correct the curve, as we since it's curved, the spinous is sitting inside the curve. As we straighten the spine out, that spinous is going to roll this way. And so that's good. If the spinous were on this side, we would spin it more this direction as we brought the short leg up. So we don't want to do that. So here's a guy. You can see we've got a little bit of a left curvature here. Okay. You can see you got wider pedicle. This one's here. You can tell the spinous is a little off to the right. And by golly, look, there's his short leg. He's got 7 millimeters. Okay. We're good because the convexity is toward the short leg side here. And the spinous is inside the curve. So the body side of the vertebra here is on the short leg side. So he's a PI6 IN4. So if we wanted to calculate that, you can do it mathematically. +6 plus a -4 is going to give you a +2 times 0.4. He's got 0.8 millimeters of shift. We take the 7, and it's a positive 0.8. We take the 7, and you subtract the 0.8, and he's got 6.2 millimeters of AD on the left. So it's still 6 plus. Okay, so that's rule number 1. Convexity to the short leg side, that's rule number 2. And the body side of the vertebra on the short leg side. Yay! Still good. All right, now here's an example of a guy. That's the grid line I was talking about, right there. Okay? And so when I talk about aligning your ruler with a grid line or whatever, that grid line also happens to hit just almost at the top of this guy's other femur, but not quite. It's a little actually below it. Okay. So he's got a short leg over here, and I'll tell you, after you calculate it, it's almost 25 millimeters a short leg, and it's 21 point something when you calculate. Notice our marker, right is right, left is left. So you got a short leg on this side. Once you go through and do the calculations, it's still in the 20s. His AD is still in the 20s. He's got a lot of leg length inequality. Convexity is toward the short leg side, and the spinous is a little bit on the inside of the curve. So he's a candidate for a heel lift. He needs one big time too, because that sucker needs to come up almost 25 millimeters, almost a full inch. So that's a lot of leg length inequality. And once again, when I was talking about grid lines, it's these things right here that I was talking about. Okay. All right.